Sir John is joined at his table right here to my left by today's chair of Working Group 1, Ching Da-He of China, by Gilvan Meira Filho of Brazil, who has co-chaired Working Group 1 and was the IPCC vice chair during the third assessment period, and by Hihui Deng, the co-chair of Working Group Number 1 from 1997 to 2002. And today, Sir John is going to remind us how far we've come with the IPCC's help in understanding the physical science basis of climate change. Sir John?
Distinguished guests, ladies and gentlemen, the slides will appear. Oh, they're appearing all right, good. The IPCC, when it began, did a new thing in science. It involved, or tried to involve in an assessment, not just a few distinguished scientists from around the world. It tried to involve all the scientists from around the world in this subject. Why? Because it's a global thing. It involves all countries. It involves all peoples. So that seemed an important thing to do. The other thing that incidentally, of course, the IPCC also did was to involve governments and get ownership from governments by the way it carried out its assessments. And the remarkable thing is, and it's still very remarkable to me and to many people, that it's possible under the honest discipline of science to get scientists of all kinds around the world getting together to decide to come up with real results. And you all know these reports. The last slide showed pictures of the 4 reports from Working Group 1. If you have enough, you can download them all from the internet. If you have enough paper, if you have enough time, if you have enough patience, and if you have enough ink. They're all there for everybody to read. And over the years, from the first report to the fourth assessment report, the number of people who were involved has increased, the number of countries has increased, the participation of the whole scientific community has grown. Just now to mention progression, how we've had progression in observations, we've had progressions in the attribution of global warming to human activities, we've had progression in our understanding, we've had progressions in the projections we made of climate change and in the acceptance of our IPCC work. Just look, there's a picture of the atmospheric temperature increase in the last 140 years up to 1990, when the first assessment report was published, and then notice how the temperature increases during the decade, or decade and a half of the IPCC reports. It's grown by a factor by the order of 0.3 degrees over that period. And it's those observations which the climate is telling us that the Earth is warming. There are lots of other observations too. There's sea level, there is decreased snow cover, there are also increased atmospheric water vapor, glaciers are retreating, the Arctic sea ice is retreating, and it's still retreating this year. Extreme temperatures are increasing. We've had many more warm years and warm spells. All of that adds up to a story of unequivocal warming. What about attribution? There's the observations you've just seen a couple of times on previous slides. If we now try to model the climate over the 20th century, what do we get? We get that blue line, and if we model it, that's without any greenhouse gases playing any part at all. And you see the observations don't fit. The red line is when you add the greenhouse gas observations to the natural variations, and you see there's a very much better fit with observations. And that fit is improving all the time until we get to AR4. And you will read on the left, of course, the statements made at the start. We said that we're going to have to wait 10 years to get an answer. And then we did a bit better in later reports, more definite statements. Just let me mention the drop in the temperature around the 1960-70 period, which is, we believe, due to very largely to the influence of aerosols. And between the first report and the second report, we began to really understand aerosols and the importance they were making, cooling as well as warming, as far as the globe's concerned. And then we made projections to begin with of what the temperature would be in 2025 or so, or for the next 20 years. And we did that working in 1990, we did that in 95, we did that in 2001, and we did it in 2007. And you see the projections we made fall within the range of the observations. We really made rather good projections, even though we weren't terribly certain about them all, and put a big error numbers on them. And now we can project that now to 2025 and what will happen over the next 20 or 30 years, and with some reasonable certainty of doing it. How much more warming can we expect? And that's the distribution of warming around the globe. Continents warm a great deal more than the oceans. And some parts, of course, particularly in the Arctic, warm up to 6 or 7 degrees possibly this century, even though the average warming may only be 3 degrees by then, under the scenario of that diagram. Very big changes in the way the warming occurs, and the impact of heat waves. We saw one in Europe in 2003, which was a very pronounced event. The hydrological cycle will change too, and we've said a lot about that in our reports. Increased water vapor in the atmosphere puts increased energy into the hydrological cycle. The blue regions there are what is proposed now under the fourth assessment report for what will happen near the end of the century in terms of the increase of precipitation in some places and the decrease in others. Plus 20% in some places, minus 20% in others. That means more intense rainfall. That means increases in drought also in other parts of the world. Some of the most important and most telling events that we will see as a result of climate change are these floods and droughts. We're seeing them at the moment. Some of them are there in the world at the moment. There's one in India which is causing great devastation, and we're seeing more of them already. We're going to see a great deal more of them later in the century. Some people have read the IPCC reports that keep coming across the word uncertainty. Lots of times the word uncertainty is used. And they say, you scientists, you're so uncertain about everything. You're always mentioning uncertainty, and therefore you don't know anything, because you're always talking about uncertainty. We've moved very substantially in the way we represent uncertainty, and we turn it into numbers. We quantify uncertainty in our latest 2 reports, which is something that scientists haven't done, I think, on the same scale, in any other area of science, because we want to say what it means. It's all very well saying, I feel a bit uncertain, but what do you mean by that? And we've quantified that in terms both of the likelihood of events and also our confidence in statements that we make. And finally, we've, I believe, made great progress in the way in which our reports have been accepted. And just to give you one example, and this is the joint science academies of the G8 countries plus China, India and Brazil, June 2005. They made a statement to the G8 conference of that year, highly headed the global response to climate change. They called on the world leaders to acknowledge the threat. They called on them to take it very urgently. And they also said, we recognize and that's a direct quote, we recognize the international scientific consensus of the IPCC. That's an unequivocal endorsement from the world's top scientists, and they've repeated it again this year before the G8 conference in Japan. They repeated a very similar statement. Finally, priorities for the future. There's lots to be done. And you can't read all this probably, but we're talking about much better information on the regional scale. We're talking about much better understanding of climate feedbacks. We're talking about much better understanding and knowledge about climate forcings. There's a great deal to be learnt, and the next assessment report will be addressing many of these issues. In particular, we need to know much more about clouds, we need to know much more about the ice sheets, we need to know much more about the ocean circulation. So there's lots to do in the future. And as I conclude, let me myself pay tribute to those hundreds, thousands of scientists who've been involved with the Working Group 1 process, with the science process, with great commitment and dedication and excitement. We've had marvellous meetings. We've learned a great deal from each other. And one of the great results of the IPCC process is that we actually have an educated science community who know not just about their little bit of science, they know about the whole breadth of science. Why? Because they've worked for the IPCC. And many of us who've been involved recall those years with the IPCC and say it's been the most exciting and the most rewarding periods of our life. Thank you very much.
Thank you, Sir John.